Today's lesson is going to be on circles. We're going to go through some definitions, some formulas, and a few questions just to help you out when you're going through this unit or studying for this unit. First thing we need to know is what are the line segments in the circle? So when we have a line segment that's touching a point on the outside of the circle and ends in the middle of the circle, that's called a radius. We know that when you have two radiuses put together, you can make a diameter. A diameter is starting on a point on the outside of the circle, straight line straight through the center of the circle to a point on the other side of the circle. That diameter can be anywhere on the circle as long as there's a straight line and goes through the center. The black right now, the diameter is in green, the radius is red. The black on the outside is like what I say when we're looking at the perimeter of some shapes. The outside of a circle is a circumference. So that's represented in black. And we look at how much is it on the outside of the circle. The last one here is the other black line in the line segment there. That's called a chord. We're not going to go too much into detail on what a chord is, but a chord is a straight line from one point of the circle to another point of the circle, but does not go through the center of the circle. That is what a diameter is. Any other line has to be a straight line that touches 2 points of the circle is called a chord. When we look at a radius, diameter, and circumference, we have to look at some formulas as well. So if I give you the diameter, your formula will be to find the radius, r equals diameter divided by 2. So if you know the diameter, for example, if your diameter is 10, it'd be r equals 10 divided by 2, r equals 5. So we know when we have two radiuses, they equal the diameter. Or if we have a diameter, we can cut that in half to find the radius. When we look at a diameter, again, if I give you the radius, your formula will be d equals 2 times r. Like I stated before, if you have a radius, you can double that, add it again, times it by 2, whatever you like to find your diameter. So if your radius was 6 in this case, you would go d equals 2 times 6. So d equals 12. And whatever unit you're working in, if it's centimeters, meters, millimeters, 12 centimeters. The next topic is circumference. Circumference can have two different formulas. One of the formulas will be c equals pi times d, or c equals 2 pi r. They're going to equal the same thing. I'll show you an example in a second. But whatever one you like to work with. Again, if I give you the radius and you just want to plug it in, substitute it in there, you can use this formula over here to the right, the 2 pi r. Or if you just like working with diameter, doesn't matter if I give you the radius or the diameter. If you find the diameter, you can plug it in and go pi times diameter, or pi times d. We know that pi equals 3.14. There's a whole bunch of digits after that. For our sake, we can keep it to 3.14. So in your calculator, you're going to punch 3.14, or you can hit the pi button. So if I was looking to see how much is the outside of the circle, the circumference, I'm going to plug in my information into here. So let's use 12, okay, as an example. So if my diameter was 12, I would write the formula c equals pi times d. Then I just substitute. Keep the c because that's what we're looking for. We haven't used pi yet, so I'm going to keep pi there, and we're going to multiply that by 12. So the next step would be, again, on your calculator, I would punch in 3.14, or I'd hit the pi button, multiplied by 12, and that equals 37.68. Again, whatever unit I'm working in, I need to put that unit there, so centimeters. We can go back and I'll check that it doesn't matter what formula we use, you're going to get the same answer. So for this case, c equals 2 times pi r. We don't know what circumference is. We're trying to find that. We're not going to use that yet because it's not in order of operations because we haven't substituted yet. Pi we haven't used, but we know what radius is. For this case, it was 6, half the diameter. So I'm going to put 6 there. Then in my calculator, I'm going to punch 2 times 3.14, 2 times 3.14 times our radius, which is 6, and you're going to get 37.68. So our circumference equals 37.68 centimeters. Okay, so again, you can see that the answer is going to be the same. It doesn't matter what method you take. The last formula that you're going to need to know is area. So the area is how much space is inside this circle. So am I shaded all that inside? So we're looking at area. Same kind of concept when we're looking at the area of a square, a rectangle, any kind of shape. Your area formula is A equals pi r squared. Not pi r times 2, it's pi r squared. So again, I'll use the example that we have here where our radius is 6, and I'm just going to plug in that answer. So A, we don't know yet, that's what we're trying to find out. We're trying to find the area. We haven't used pi yet, but I'm going to plug in my radius, which is 6, and I'm going to keep that exponent that's attached to it. So again, we know from our exponent lessons that 6 squared is 6 times 6. So we're going to answer that, and we're going to go A equals pi times 36. So at that point, again, I don't expect you to know how to multiply 3.14 times 36. So on your calculator, you're either going to hit the pi button or you're going to type in 3.14 times 36. And you're going to get an answer of 113.4. Decimal 0.04. And again, we're working in centimeters because it's area, we're going to look at squared. Somebody's going to ask me, well, how many decimal points do we put? You can put 2 decimal points to the 100th column. So that's how we find area, again, substitution. The only other thing that you will need to know is if I give you either the area or the circumference and I ask you to find the diameter, or I ask you to find the radius. So for example, again, I'm not going to try to confuse, I'm going to use the numbers that I have up here anyway, but let's say I have a question that says a tree is 37.68 centimeters in circumference. Tell me what the diameter is. Again, we're going to use the formula of circumference because that's what we have information for. So C equals pi times D. Now we want to find diameter by knowing circumference already. We know that circumference is 37.68, so I'm going to substitute that in. We're going to leave pi, and we want to find out D, diameter. So from what we know from algebra, when you have a coefficient attached to a variable, to get rid of that coefficient, you need to divide it by itself. So I'm going to divide by pi on this side, and I'm going to divide by pi on this side. When you divide pi by pi, 3.14 by 3.14, it's going to equal 1. You don't have to write 1 in there. If a d is by itself or diameter is by itself, we know it's 1 diameter. Okay, so you don't need to put 1 in. As long as the variable is there, I know it's one of those. All right, so these cancel out, and then 37.68 divided by pi will equal 12. I know that because of my answer before, but you can type that into your calculator, 37.8 divided by 3.14, and you get D equals 12. All right. At that point, again, if I want you to be real particular how you format these questions. So I need the formula. I need your substitution line where I'm plugging in the information that I have, and then your answer. Okay, and then if it's a word problem, state the answer. So if I asked you what's the diameter of that tree if the circumference was 37.68, you would write the tree has a diameter of 12. Again, we'll put our units. So D equals 12 centimeters. And I would write the tree has a diameter of 12 centimeters when the circumference is 37.8. Formatting this way, A, I can figure out where you went wrong. B, you can get part marks even if you got it wrong. And C, you can see the format, especially when the questions get bigger as you get older. Make sure there's only one equal sign in each line. Okay, you can't have things equaling. They don't all equal each other. The last question that we went through is when you have a tray that is, let's say, 20 centimeters by 25 centimeters, and you have cups that have a diameter of 2 centimeters. How many cups can fit onto that tray? So we need to look at diameter, and we know that vertically and horizontally they're 2 centimeters. So if I put cups horizontally across this tray, we got to see how many times 2 can go into 20. We know that 10 cups can fit horizontally. Again, that's not 10 cups, but that's enough for our drawing. Then we got to look at how many cups can fit on vertically. So how many cups can fit on 25 centimeters? 2 doesn't go equally into 25. We can't have a cup hanging over or it's going to fall off. So if I go to 13 cups, that equals 26. That 1 cup will fall off. So I got to go 1 less. So it's going to be 24. So 2 times 12, okay, equals 24. Make sure I have space so that I know that we have 12 cups. So I have 10 cups going this way, and then I have 12 cups going this way. What I just did was draw an array. Instead of having to draw the whole array, again, I'm going to use my calculator, or if I know this for mental math, I'm going to go 10 times 12 equals 120. So 10 horizontally times 12 vertically equals 120. So again, my statement would say 120 cups can fit on a tray that has the dimensions of 20 by 25. Again, I don't need to draw out the whole array. I can figure that out by going 10 times 12. I don't need to take cups out and put 120 cups on a tray and try to figure it out. This is the way that you can do it. If you have any questions, please come and ask. Hopefully this helped you a little bit on the formulas, some definitions, some questions, how to substitute, how to format. That's very important, especially going into high school. Like I said, if you have questions, come see me tomorrow. Come see me this week. If not, you can watch the video again. Maybe that'll help you. Maybe you missed the important point in this video. Until next time, enjoy.